This one's for the boat. Okay, so read that problem. See if you can come up with some kind of picture to draw. At some point, too, I'll show you the Larson book. The Larson book has all the pictures in it. All right, we could edit this out. So let's label our picture. Did anybody put anything on their picture?
I put 3 meters for the
height. Yeah, good, because that's going to be a constant.
I put R for the hypotenuse.
Okay, because it's a rope.
And then I put V for the second leg.
Did you?
For velocity.
Okay. Did anybody else put a different letter? Because I'll use his because he has one already. Okay. I usually do B for base, or W for water, or X because it's an X. You know, whatever. Doesn't matter what letter. Alrighty. So that's perfect so far. What kind of in the equation do you think you guys can write? Oh, wait. Let me go back. We should write our given and what we want to find. Okay.
Yes.
All right.
Given is 2 meters per second.
But not because it's always right, but because...
Right, that's what I was going to say. You said D what dt?
dr.
dr dt, right, because it's the rope. Okay. There's actually a little nuance here, a little extra thing if you think about it. And somebody asked a question then. Did you?
Yeah, is this going to be an equation with 2 variables?
Not with too many, Like it'll only have 2 variables. So did the last one really with the A and the R. Yeah, it'll be when there's 3 variables that we'll have a problem. This R, okay, think about the last one with the circle. Okay?
R is getting shorter.
Yes, R is getting shorter. So what do you think I should do with this?
Negative.
Make it negative. Good. Okay.
Is that a V?
Yes.
Okay.
Or is it a little birdie? It's a little seagull.
Well, a
Yeah.
birdie, or like a really wide R.
Yeah. Oh, okay. Yeah.
I
I put up.
don't know why it would be an R.
It's a caucus bird. What's the V for?
Well, he said for velocity, but I mean, you just needed a variable down here. V's for variable.
V is for
Yeah. Okay, the end of the rope is 3 meters. We did that. You're pulling the boat inward by pulling the rope at 2 meters per second. We did that. How fast is the boat approaching the base of the pier? Find. How fast?
dv dt.
Okay, yes, good. Let's find how fast the
When?
boat's approaching the pier.
when R equals 5.
Excellent. That looks like such a fancy W. That was a pen thing. That wasn't me. I like the W. It did it itself. Yeah.
You like ad-libbed.
All right, so what equation could we write?
It's a triangle.
Mm-hmm.
Is that what it's going to be?
Uh-huh. Okay.
V squared plus 3 squared equals R squared.
Perfect. Yep. Say again?
You look like Al.
Oh, okay. All
R
right.
is 5.
So, okay, now, I'm glad he said that. Did you hear him say R is 5?
Yeah.
Okay. Now, anytime you put in any of this information, if you put it in 2, or like, what is our step that,
We have to differentiate first.
Yes, because if you differentiate when variables are variables, one thing happens. But if you do it when numbers are in there, something completely different is going to happen, right? So you want to differentiate, and then, yeah, we'll go with, at that point, what the numbers are going to be.
Oh. What? Oh. Wait.
So-
Oh, okay.
Got it? So what's the derivative of...
2V
Mm-hmm.
dV dt.
Yep.
Plus 0.
Awesome.
2R dr.
Yep. Okay, so let's get dv dt by itself first. So it's 2r dr dt, because the zero's gone, divided by 2v. And the 2's are gone, so it's just r dr dt, all divided by v. Okay, so let's plug in the given information. R is, all right, 5 meters, and I'm going to put the units in. dr dt,
Do they give us a beat?
hmm?
They give us B?
No, they do not. Now let's go back to what did Logan say and why?
R is
Okay.
5.
That wasn't what he said. I don't think that was what I heard. Or was it?
That's it.
Long time ago when I said don't put numbers in too early.
He said
I
R
s-
is
Yeah, you said
five.
R is 5.
I thought he said V was
It's
something.
4.
That's what I thought you said.
3, 4, 5.
Yeah, it's a 3, 4, 5 triangle.
Oh, it is.
Yeah, so this is the when, okay? When R is 5, V is 4. So that's when you put in the 4.
'Cause
Okay.
you can get V from that.
Mm-hmm, right. So if it wasn't as simple like 3, 4, 5, or if you didn't have 7, 12, 13 memorized or whatever, this, and if it wasn't special, it might not be a, Pythagorean triple with integers, then you just use the Pythagorean theorem to get the third side, okay?
What should we use B? D for distance.
Oh, that would have been really
I-
crazy
I-
with D's and R's and dr,
Yeah,
dt.
and
Be like,
dd,
oh.
dt. I do use
DDR,
dd, dt
DDR.
when I'm doing the distance formula.
Because now that the base of the triangle right there isn't velocity yet. It's just distance.
Mm-hmm, right. And they're all velocities and they're all rates. I was going to say that when you
Yeah,
said V for
because
velocity,
is-
they're all
is a rate.
velocities, yeah.
Yeah.
That's why I usually use B for either base or for boat, but whatever. Okay, and let's see, so now your 2 and your 4 cancels, right? So it's 5 halves, negative 5 halves.
Is-
Oh, that's a highlighter.
That's how fast it's speaking.
Yes. Meters per second. And that's at that instant, right? So I mean, think about if this boat was 50 feet out, and you're going like this, versus if the boat was like 6 inches away, So God bless you. So if you did find these things at different when R equals values, you would notice that it's getting quicker the closer it's getting.
Could you find this out this could you solve this problem without calculus? Or is there no
I don't know. I don't think so. Because the one,
Calculus is the
because
only way.
calculus, no, I'm going to say definitively no, because here's the deal. And the more into calc you get, the more you're going to realize when you don't need it and when you do, okay? So I was just doing problems with Brittany on work. Now, yeah, work equals force times distance.
Right.
When it's a constant force, you just take force times distance, right? When I'm compressing a spring, that's not a constant force. The more I compress that from, my force is changing, okay? So I have a variable force. When you have one thing that is variable, then you require calculus. Because in that case, work is the integral of force times distance as you're moving from this distance to this distance. Because the force is inside there, and the force is a function of your distance, and it's by Hooke's law, it's proportional to the distance away you're going. But because the force is variable, you're allowing for that variability through the integration component of calculus. So no, anytime something has one thing that varies, you're going to need calculus. What was your hand up for?
I was gonna ask, how would you know when to draw a triangle? Because I would have just drawn a straight line.
Yeah, on this one, I
Yeah. Well, okay, but then let me ask you that. Your straight line would have been how far the boat was from the pier, right? Or, okay. But then you would have been going, what am I going to do with this tube? You know, because you're pulling your rope at 2 meters per second. You weren't picturing your rope like laying in the water, were you? Or were you?
I was picturing it 3 meters above, across all the way.
So your rope's going like this.
So your